Thank you very much for the time. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today I will present about my our study report with the title "Study on the Analysis of Demographic Data Based on the Spatial Information System." We are from Department of Geodetic Engineering, Diponegoro University. The basic idea for this study is about we have not a problem with our demographic data. For example, aid and charity distribution. Now, in COVID-19, uh, many poverty people not receive uh, the aid or charity, but many people should not receive this aid on charity. And also, but our big population in Indonesia, so we need to uh, systematic report for the many application, many function, and also many policy in demographic. This problem is caused based on the uh, different data from central and local government and also between agency. We know different data from central and local government, for example, data poverty people different. So many people should receive the charity or aid based on the district data, but in the village data is not record, so the people is not receive the aid or charity. Also between agency and also the different time unit. For example, from local government use the first time is September or October as the first time in year, but central government use January, February as the first time for the year. So this different time is make data is different. And also the demographic data is still not based on the spatial, still based on the tabular data, so it's very difficult to implement it in our country because we pick area with the after I'm sorry every location. For example, every area in Indonesia have a special character in Java is different with Kalimantan, Sumatra, and other. Based on this problem, we try to make a goal in this research. The first is about what if demographic data is implemented on geographic information based dashboard and how is the impact spatially. The first we try to introduce about the multi-dimensional database system. We can see from the figure uh, three dimension about the spatial indicator and also time. With every dimension, we have hierarchy. For example, in spatial, we can see uh, the lower level of hierarchy. We can see the village and go to high level district vacancy and so on until country. And also in time dimension, we have day, week, month, until decade, and also indicator in lowest level until indicator in the higher level. In this uh, multi-dimensional database system, we have a small cube for implement the fact about the information about the spatial indicator and time dimension. The fact contains the value of the measure for particular combination dimensions number. Based on this concept, we get the implementation. For example, we have some small cube. This small cube represent about the some village as the lowest level of spatial dimension. We have indicator 2 and indicator 3 as the lowest level of indicator dimension, and also year from 2016 and until 2019, for example. Every small cube have the value. The value will describe about the particular location, particular indicator, and particular time. For example, the first small cube with the value is 1 or the value is 4 describe about the data in the village 4, indicator 2, and in particular time that is 2016. And based on this organized small cube, we can the process about the aggregation process we can do based on the hierarchical level for each dimension. For example, in spatial dimension, we can see from village level to district level, regency level until province. So the concept of aggregation is the accumulation of value. For example, we have some value from village level. It can be aggregated to a simple value in district level and also regency level until province level. For example, this one we have some value from village 1, village 2, village 3, and village 4. We will aggregate to the based on spatial dimension. Village 1, village 2 become district 1, village 3 and village 4 become district 2. And the value from village 1, village 2 accumulation become value in district 1. We can see the chain of aggregation process. Aggregation process also can be done in 2 dimensions. For example, spatial dimension in indicator dimension. For example, in indicator dimension, we have based on the gender, male population and female population, we can aggregate become the total population. So the aggregation will become accumulation data from district 1 and total population in district 1. After we have the data from multidimensional system, we can implement it in spatial information system. So the small cube in multidimensional database system is represented about the specific location in the map or in the geographic location. For example, in this district of Purwosari in Gunung Kidul, Yogyakarta, we have some village, for example, Girijati, Giriase, Giricahyo, Giripurwo, and Giritirto. We can implement it every value in this small cube transform to the map. Based on this map, we can get the symbology based on the higher value to the lower value. For example, the higher value of female population, we can see this is the Giripurwo. And the impact for this implementation in spatial information system is, we can see after the aggregation process, for example, from district level, sorry, no, from village level to district level, we get some impact. The versus for scaling, the scaling from village level is more height is higher, sorry, is higher, and scale in district level is lower than in village level. So, and the second is generalization. So the information from village level we cannot see again in district level. And also the classification from the village level, we can see the classification is uh, more variation of classification, but in the district level we can see uh, very simple classification. We can see only 1, 2, 3, 4 classification, but in the village level we can see more than 4 classification. But after we try to process aggregation in the indicator dimension, this is not impact about the spatially. For example, we aggregate from female population and male population become total population. So this is aggregation based on gender. We can see from female population we can get the same scale with the male population and also same scale with the total population. But the classification we can see in female population 1, 2, 3, 4, 5, 6 classification, and also we can see in total population also 6 classification. So with this the result and analysis, we can get the conclusion. The first aspect to enter the raw data of its indicator on its small cube presenting its fact in the cube that identify the 3 dimension, that is spatial, time, and indicator. So the smart cube in cube perspective contains spatial information is it as if were a map that represented object on the Earth's surface. So every small cube represented one object in the Earth's surface with the value and with the classification, with the generalization. Aggregation process or transformation process between hierarchical level in the cube uh, in principle is operational process value raw data in the small cube. However, in a map, this change not only affect the value but also affect the map scale, generalization, and classification process. This is can be seen in spatial dimension. That is our report research. Thank you very much for your attention.